Trigonometry involves triangles. It relates the angles in a triangle to the sides of the triangle. Here's the usual triangle ABC that we had when we looked at the sine rule in the previous video. So this video is looking at the cosine rule. If I draw in a height from this point C down to the opposite side AB, making that right angle, and call the height H, we've got two right angled triangles. C has been divided into this length X, right up here to where the height meets the side, and so the remaining part of C in here is length C minus that X. So two right angled triangles. The one on the right has hypotenuse A and shorter sides H and C minus X. Apply Pythagoras' theorem, and A squared, the hypotenuse squared, is H squared plus all of C minus X squared. So C minus X in brackets. Squaring it, C minus X times C minus X. If you break the brackets up, you get C squared minus 2CX plus X squared. Going to rearrange that, gathering up the H squared and the X squared. If you look at the left-hand triangle and apply Pythagoras' theorem, hypotenuse B squared is equal to H squared plus X squared, and that means this H squared plus X squared can become B squared. If I apply trigonometry to the left-hand triangle with angle A and involve the X here and the B, the side of the bigger triangle, then we've got cos A is adjacent X over hypotenuse B. Rearrange that by multiplying both sides by B, brings the B up to join the cos A, and X equals B cos A, and this B cos A can replace that blue X here. And there it is. A squared equals B squared plus C squared minus, and this is 2CB cos A, so we'll just change that to 2BC cos A, and that's the usual form of the cosine rule. A squared equals B squared plus C squared minus 2BC cos A. Now, it looks like Pythagoras here. A squared equals B squared plus C squared, and it is. If the angle A is 90 degrees, that's a right angled triangle. Cos 90 degrees is 0. So minus 2BC cos A becomes 0 and disappears, and we've got Pythagoras' theorem. So you can think of this as Pythagoras' theorem modified by this minus 2BC cos A for triangles that are not right angled. So this will work in all triangles. In the right angled triangle, it just becomes A squared equals B squared plus C squared, Pythagoras' theorem. So here it is. That's what you memorise, that's the cosine rule. Importantly, if you're trying to find out angle A, you would need to know side A. If you're trying to find out side A, you need to know angle A. In this case, this is for working a side out. It's what A squared equals, small a. So to work out side small a, you need to know angle A. So you need to be told this angle. You need to also know B and C, the two sides of the triangle. So it's like the hands of a clock. It's two sides and the angle in between. So if you know the two sides and the angle in between, you can work out the side opposite to the known angle. Here's an example. Two sides and the angle in between. We have to find out PR, the opposite side to this 82 degrees. So that two sides, the angle in between, that tells you cosine rule, and we're working out the opposite side. So that's for working with the cosine rule. That's the information we need. What I'm going to do with this example is remove the lettering P, Q and R, and since we're using the cosine rule and we need to know angle A, I'm going to call this corner here A, and opposite, the side we're trying to find, is small a. Here it is here. So lots to P, Q and R, and we give it lettering, it will fit the formula. So all you do is now put the numbers in. Angle A is 82 degrees, to replace A here, and B and C, doesn't matter which way around they are, they replace the B and the C with the 6 and the 5. So there's the B and the C going in, and the 82 degrees for the A. You put that into the calculator. You don't try to work it out yourself in stages, you just put that into the calculator, press equals, don't round anything off. That's what A squared is, square root it. write down the unrounded answer, and finally round it off. And since A was originally PR, it's PR equals approximately 7.3. So that's to find a side, this form of the cosine rule, two sides and the angle in between. Simply put the numbers in the calculator and follow it through. If we're asked to find an angle, we would need to know its opposite side, and we've got a different form of the cosine rule. It's simply the previous form rearranged. So if you rearrange the cosine rule, you can get it into this form where cos A is b squared plus c squared minus a squared over 2bc. Now this minus a squared is important because side A here is being squared and it's opposite angle A. So you've got to make sure when you use this form that the minus side squared here is the side opposite the angle you're trying to find. So you need to know A, B and C. You need to know all three sides, but the minus a squared is the bit you've got to be careful with. The B and the C doesn't matter which is which. They're being squared and added in the top and they're being multiplied in the bottom. So here's an example. We've got all three sides. We're trying to find out a missing angle. That tells us to use the rearranged form of the cosine rule. Or to find angle PQR, that is the angle at Q. So we want this angle here, opposite is a 9. So we get rid of the lettering, P, Q and R, and we change this Q into A. And opposite side A, the 9 is side A. So we know three sides, we're finding a missing angle, it's the cosine rule. The side we've got to be careful with is which side is small a, and it's the 9, because we're trying to find the angle here, which we'll call now corner capital A. Here it is relettered. Trying to find angle A, opposite's the 9. This minus a squared is minus 9 squared. Otherwise, B and C, doesn't matter which way around they go in. You simply press the fraction button in the calculator, put in that top line, put in that bottom line. Don't try and work it out yourself. Press equal to in the calculator. This is cos A. This is negative a third in this case. It so happens the top line came out to negative 20 and the bottom line to 60, and that simplifies to negative a third. To get A, you need to get rid of this cos, so you inverse cos to get the angle. Write the unrounded answer and then round it off. We called this A, it was originally Q, so it was originally angle PQR. So it's angle PQR, it's 109.5 degrees. So that's, to find a missing angle, you need to know all three sides, and you've got to be careful which side is A, because that's got the minus side squared. Here's some examples on a worksheet. If you use the link in the description, you can download the worksheet and it'll have the answers. Otherwise, pause the video for a few seconds to do the questions. Here are the answers. Pause the video if you want to check them, if you've not downloaded the worksheet. And here's an example on applications. So this is applying the cosine rule. This says a ship travels 9 kilometres from P to Q in bearing 125 degrees. So there's 9 kilometres P to Q, bearing clockwise from north 125 degrees here. It then sails from Q 12 kilometres to R when bearing 260 degrees. So there's Q to R's 12 kilometres, bearing clockwise from north 260 degrees round here. And you have to find the distance of the return journey R to P, RP. So you want this line RP. What we've got here is three figure bearings. That is to help you work out missing angles in the triangle. Now you can use either F or Z shapes, corresponding or alternate angles. For parallel lines, corresponding angles are equal. For parallel lines, alternate angles are equal. Here, corresponding angle, A and A. This is the supplement 180 minus A because you need to make a straight line here. So it's handy to see on the inside bit of an F shape, the angles add up to 180 degrees or supplementary. So when this is 125, this is the inside bit of the F shape, it's 55 because 125 and 55 make up 180 degrees. Around a point is 360 degrees, so this missing angle must make this around the point up to 360 degrees, so this is 45. We have to work out RP, that's the side we're working out. What we've got is two sides and the angle in between. We have to work out the side opposite the angle. That tells you it's a cosine rule, not the sine rule. Now, we're going to get rid of all these north lines and all the unnecessary pieces of information. We just need to know 9 and 12 and 45 degrees, and we want to find out this side RP. So getting rid of everything except what we really need. There it is, two sides, the angle in between. We want to work out the opposite side, and I've labelled the side we want to find A. So opposite angle A, the other two sides are B and C. That's so that we can fit it easily into the cosine rule. So we do what we did before. You just put that in the calculator. Don't try to work it out yourself. Get the unrounded answer. That's A squared. Square root it. Unrounded answer. It's rounded off to 8.5 kilometres because we're dealing with a journey there. And originally A was R to P. So it's RP is 8.5 kilometres. That's it done. There are 4 questions like that on a worksheet. One of them involves the other form of the cosine rule to get a bearing. If you download the worksheet using the link in the description, it will have the answers. The worksheet for the first exercise in this video is on the link from the description. This worksheet on bearings is also there. That's the 4 questions. That's the same questions with the angles you're after, and there's the answers. So if you download these, there's also a set of notes there which covers all the videos on trigonometric formulae. So it's got the sine rule, it's got the cosine rule, it's got examples on everything that's coming up. So if you download these worksheets, you don't need to listen to the rest of the video because all I'm going to do is go through the questions and answers for those that haven't downloaded the worksheet. So hope you found this video useful. The next video will be on the area formula. Thank you. And if you haven't the download, there's the first question and there's the answer, 5.0 kilometres. Here's the second question. And there's the answers. That's the angles that you should work out. That's using a Z shape. And there's 12.9 kilometres from A to C. This is the third question in the worksheet. And that's the answers with some angles worked out, so you can use the cosine rule. A to C is 14.8 kilometres. And this is the last question, the fourth question. And that's the answers. This is the alternative form of the cosine rule. Work out this missing angle in the triangle, and then around the point 360 degrees, that's a missing angle inside of an F shape, supplementary, make 180 degrees. That's it written as a 3-figure bearing. That's the worksheet, and that's the end of the video.